Go 1.23 release notes. Okay, so there is something in here that I actually did want to look at. I really wanted to play with this right here. So we're going to look at this for a second because obviously Go has been making some big moves. Ever since, I think, what was it, 1.18? I think that's when generics happened. I feel like Go, since 1.18, has been really moving and is actually making some big changes to the language in pretty meaningful ways. The latest Go release, version 1.23, arrived 6 months after Go 1.22. Most of its changes are the implementation of the toolchain, runtime, and libraries. As always, the release maintains the Go 1 promise of compatibility. We expect almost all of Go programs to continue to compile and run as before. There was one thing that people got really upset about in this whole Go thing, and I think they're specifically calling this out due to people getting really, really pissed off. But I would say people got upset because the world's longest standing bug and Go's refusal to just move as fast as they have been caused a bug to become a feature for a long time, which is, for those that don't know, is that in a for loop, it would use the same piece of memory and update it as you go through a for loop, which means that if you reference the variable that's coming out of a range expression, it would actually change out of underneath you. I got hit by it on stream. Like, I thought I was using the right version of Go. It turns out I wasn't using the right version of Go, which is this thing that allows it so that if you're ranging over a table or over a list, you won't actually, or a slice, I guess, in language, it will use new memory locations for each one of them. And so that way, if you reference it, you won't get explodiated. It was pretty great. And now that I know that, it just makes me kind of laugh. All right, so here we go. So this is the one that I was very excited about right here, is this one. Go 1.23 makes the Go 1.22 range over function experiment a part of the language. The range clause in a for range loop now accepts iterator functions of the following types. Okay? This is going to be kind of interesting. As far as range expressions, calls of the iterator argument function produce the iteration values for the for range loop. For details, see the iter package and documentation of the language spec. For motivation, see the 2022 range over spec discussion. Go one. Let's see. Okay, so they also have generic type aliases. I'm not as interested in that as I am in this. So let's actually build. I actually wanted to look at this and build an iterator. Let's build an iterator in Go because I heard it's generally kind of gross. All right, so let's look at how this actual ranging iteration business works. Because I actually did want to see this. I really did want to see how this thing works. Okay, so let's make a map function, right? A map function takes in any. I'd assume I had to do. I assume I have to do like an in and an out, and I'd want to do an in. Oh, do you do a boolean? Do you do a boolean? Oh, you can't really map it like that, can you? Oh yeah, of course. I'm doing a map in my head. I'm doing the wrong thing here. Okay, so I do an in. And so we do a yield function. So I don't really understand what yield. Okay, so yield is the name of the func being passed in, right? That's a little bit confusing. That's why you use a yield right here. Stop boolean me. Boolean. Boolean. So, okay, so we are a func that takes in an array, and we take in a function as an argument that is an int, which is an index, and the thing we want to return. And we return a function called yield. Okay, hold on. We are a func that returns a func that takes in a func. Okay, there we go. I got it. We're a func that returns a func that takes in a func. So we return the function yield that takes in we return the function that takes in the function yield. Then we go over our collection and we yield this out. Okay, there we go. Now we understand it. So what I'm going to do is I'm going to go like this. I'm going to -1. Can I just go like this? Can I take out the genericized version of it and just have it as an int array for now? Right? I think that should work. I think that does work. And so let's just have something that literally goes over that. So I should be able to go like this. I should, theoretically, be able to go foo equals int 1, 2, 3. For, let's see, v equals range Or can I just go map? Is it range map? How do I even use this? Range slice backwards. Okay, so it is. Okay, so I should be able to go map foo. Did I do that right? Cannot range over map. Invalid range expression. Why? Why? Por qué, Maria? Do range. All right, is it because I didn't make, is it because it's not a generic? Is that really the problem? Does it have to be genericized? Or am I just too stupid to use this thing? LSP does not support it. Oh. I really hope that's not the case. That better not be the case. I refuse to believe that. I refuse. Go, run, command, main, go. I'm confused as to how I got these values. Here, hold on. Format, let's see, format, yep, print, F. All right, I, V. There we go. I got a little bit confused over that. Wait, why did it say that? Why am I getting extras? I'm not getting, oh, wrong thing, sorry. I've been in Zig for too long. I forget that you have to hit him with the D. All right, so I equals 2. Oh, this goes backwards. That's right. I'm ranging backwards through the list and minusing 1. I forgot that I'm going backwards. Huh. Okay. Big D. Yeah, we got the D. All right, so there you go. We've range functioned. All right, so here's what I'm going to say. I feel like it would have been way cooler to have some sort of like what's called type iterator interface that just simply had the word next, which should return out, you know, or maybe it could have different types, right? Something that returns out something like that. I'm not really exactly sure how they do it. Pretty much the same thing as this thing, right? Keep on yielding and then return eventually. You're thinking in Rust, but I'm also thinking in Go. It would be nice to be able to have something that was a little bit more. I'm not exactly sure how. I'd have to think about this interface more because this isn't quite right. You'd have, it would keep on calling next, and so you wouldn't have to yield yourself, and you could just use state. I don't know why, because I mean they do that for writers, right? For those that don't know, like if you go to is it IO that has writer? Yeah, you have the writer interface. So they already have ideas like this that you can iterate on top of. Go ranges seem funny. Yeah, it just seems super funny, and I'm not sure how I feel about it. It just feels like, I'm not gonna lie, this kind of feels like crap. I'd rather create an object that keeps track of its state, and then you could call next on, and it would return whatever out. I feel like that's much easier than this. This feels confusing, and so my guess is the reason why this exists this way is probably A, it's really easy to compile into. I assume that it makes the code very, very simple. But B, my guess also is that it's so hard to use that you won't use it much. And maybe I'm missing like a play where how they did generics, that this will become a lot easier once you have generic. Because I don't really understand Go generics. I honestly never use them because of structural typing, right? This feels like the polyfills in JS. Yes, it does. It feels like the polyfills. Seems convoluted. Honestly, as someone who's programmed a whole bunch, like for many, 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 many years, and I feel very adept at programming, this feels hard to understand. The fact that I have to yield something out to be told that it actually broke from the loop seems crazy. It kind of seems like that should be handled by it calling next, not by me seeing if it was broken, right? Because that's why you have this yield right here, is because this yield is actually to prevent a break. So it just feels funny, right? Because if I go like this, if v equals 1, then I'm going to go like this. Format, print, f, I have broken, right? Returning from loop. There we go. And so if I go right here and do the exact same thing, you'll notice that it has right here. So you can see it. You can see it in line. So it operates exactly how you would expect it to operate. But I mean, I don't often think Go misses much. I think Go is a great language designed for what it's supposed to be, a simple language able to move quickly in, and you just rely on simple features and you rely on structural typing. I think that's the big thing about Go is that you just structural type things and it just makes it really, really simple. And it just makes it good. Like, I don't want to look at code like this. I just don't. What's yield? Yield is just the name of the function, which also feels weird. I didn't realize that you could actually name. I mean, I should have realized this. It's so stupid. This is just an argument, but it feels like a weirdly named function, but it's just an argument, right? It would become more clear if I typed it like this here, right? Now you can see this. It's just a yield named int, right? That's all it is. It's just that it just looks funny, right? That's all it is that's just an argument, right? It is confusing. Took me a while to realize that yield was not a reserved word. Same here. It took me a while as well. Just because, again, when you overload a word, it can be very hard. 3 funcs. The first func is the constructor. Second func is the iterator. Third func is the callback to the loop. Yes, exactly. I would much rather, for me, it just seems like I'd rather have like an iterator interface because it's structural, which means I can make anything into it. So the part that I really like about that is that if I want to do it this way, if I want one of my objects to work, instead, I have to create the iterator interface. Then in my constructor, will take in that iterator interface, and I will produce back out something that calls next when yield doesn't fail, if that makes sense. That's the only way that I will be able to kind of use it and construct it the way I want it to behave. It's still going to have this semi kind of confusing style. But you will be able to effectively, you can imagine that I could do something that's like this, and I don't know if you can't really do generics. The thing is that generics in Go is also funny because you can kind of do generic structs. If I'm not mistaken, you can do this with like foo. If I go like this, any, and I have a foo, right? I believe I can return out something that's kind of wild here. I'm going to leave it. I believe I can return out a struct that has an int that has a foo e. Right, or type, right, I think I can do that, right? So I can go func e. Yeah, there we go. And then I'd have to figure out how to type this thing. I'm not really sure how to type this thing. But I would assume that you'd have something like a type, because I've interface up here that would go and do it, right? And then you could create something that does an ifoo. There you go. I'd assume that's how this is done, because I've seen some libraries have generic structs, and I was like, how do they create generic structs? I don't understand how generic structs are created. And there we go. I assume that's how. Check it out now. The Func Soul Brother. Yeah. Anyways. There we go. Could I see it being used to... Yeah. Genuine question. What's the usage of this and when should it be used? I saw people use it for... Gosh, I'm trying to remember what it was used for. We just used it recently. Someone had generic structs being created. I think the problem is I feel like... Here's going to be my real take with Go. I feel like Go, in its pursuit of simplicity, has taken one too many shortcuts in simplicity and caused complexity. This feels complex. This does not feel simple. This honestly does not feel good. I really wish they would have thought more just about the interfacing type and would have just created that, because that just feels right, like a good interfacing type. It just feels the Go way because everything else is very structural typing. And so when it's like, but I understand, I guess, the counter reason why is that if you have structural typing and you use an interface, all of your ranged loops will be indirect access. And that could be quote unquote slow, maybe. Maybe that's the argument. That's kind of, I guess, maybe that's part of the reason. I guess I never looked at the discussion. That func map code blocks make me sad. Exactly. The motivation was speed. Yeah, so I think I was right. Am I right on that one? I love Go. I do too. I actually think Go is one of the most beautiful languages due to its simple typing plus structural typing. The main motivation is speed. Okay. Yeah. Also, interface is pull instead of push. I think it's better. Let's see. I think that is better for iterators. Yes, I do like. So yeah, I guess another problem is I'm also thinking of pull as opposed to push. You're right on that one. Pull. You're probably absolutely right on that one. Pull makes more sense if you can treat your iterator like a burrito, commonly referred to as a monad. Since these aren't really being treated as a monad, you're not really chaining a bunch of these things together. Maybe it makes more sense to be a push as opposed to a pull, which I think is fair. Let's see, I have a question from someone who barely writes Go. Is it a big deal that they promise backwards compatibility? I think it's always a good, generally speaking, I think this is a good move. Generally speaking, you can do a foo in a struct foo. Oh, you can just do that. Oh, okay, cool. Okay, is that how you do that? Okay, I was wondering how you do it. I always forget that you can do types can be, like anonymous. They can be this weird anonymous style like this, right? This is pretty cool though, right? I mean, this is pretty cool that you can do this. I actually like that about Go. I think that this is actually one of Go's strengths because it really does make the generics very interesting, because people always said that the generics didn't work because you couldn't do this, but now you can make, you can now do data structures in Go. You can officially do data structures in Go by doing function generation with generics on it. Type generation with function generics. And I actually think this is really cool. I'm excited about range functions. I'm going to have to play with range functions more, and maybe there's a nice way to make this so that it works out just nice, because I bet you I could do something like, if you have a struct, right? Say you have a type, you have a foo, right? I know I'm using foo a bunch here. We're just going to dap all that away. And you have, I don't know, count, which is an int. You could, theoretically, you could have some sort of func f foo and have an iter that's going to return out a, right. It could return this out, right? So you could actually have that attached to it. So that way you could go, you could have this whole thing. Let's go here. I'll go like that. We'll put it into here. There you go. This is a backwards yield, by the way, so just deal with it. There we go. And so, I mean, theoretically, I can go foo. Let's see, I can go. This is how I had imagined using it, though, right? Count 10, right? And so then I can go foo.iter. I assume that should work. There you go. Yeah, it's not bad. It's not bad. It's just not necessarily the way I'd want it to be. But this isn't bad. Right, so you can attach it to things. You could make it like this. That means you could also have functions that take in iters. Iter seek simple. Yeah, I'm sure they have a whole package of iterator stuff. I'm trying not to look at their iterator stuff. I'm trying to look at it from just the raw points. I'm sure their whole iter seek, which is pretty cool that they do have this new iterator package, because I am actually curious of these things that they have. It looks like they have useful items in here. 2 versions for each. Why? Well, because there's 2 different ones, right? There's pull, which only takes a value, and then you have one that's like over a map, right? Whoopsies. Why didn't that work? You have one that's over a map, right? So this is over a map, so it takes in a key and a value. Just like a sequence can sequence over an array, or can sequence over an indexable object, such as an array, and you get the indice back. Ran out of function names. Classic. They actually just ran out of function names. And actually, they were going to call this one Sequence Boogaloo, but they decided to go with 2 instead. Anyways, okay. Let's see. Is there anything else? Oh, so telemetry. So this is actually a pretty hot topic right here. Starting in Go 1.23, the Go toolchain can collect usage and breakage statistics that help the Go team understand how the Go toolchain is used and how well it's working. We refer to these statistics as Go telemetry. Go telemetry is an opt-in system. I know there was a whole bunch of people that got really pissed off about this, and even I was pretty skeptical of adding in telemetry, but if it's purely opt-in, I don't see what the problem is, right? I don't actually see what the problem is. If they're like, hey, we want to collect telemetry on things that are breaking, and it's open source what the telemetry is, and it's opt-in, then I'm fine. Opt-in for now. Yeah, I mean, if they change it from opt-in to opt-out, then I think it's bad. I would be surprised if they change it from opt-in to opt-out. All right, is there anything else in here? So the telemetry thing, I think, it was a big deal. Now it's not a deal at all. It's just a nothing, right? It's literally just a nothing. Russ Cox quit the Go team. I didn't know about that. I'm not necessarily, by the way, I'm also not against tool chains adding telemetry. And hear me out. Like, I'm not against VS Code having telemetry. I'm against the fact that VS Code requires telemetry for you to be able to use features such as Copilot. Like, I'm actually against that as a fundamental premise. If you say, hey, as engineers, we want to be able to collect feedback. If you let me use feedback, then we can make your product better. And it's opt-in. To me, VS Code, that's fine. I think NeoVim could do the same thing. I think anything could do the same thing if you let it to be opt-in. I think that that's perfectly fine, and I don't take any offense to that as a developer. It's when it's the other way around, that you can't use all these features of VS Code because you don't have telemetry on. To me, that just seems fundamentally broken, right? I feel like they put it on by default, and they force feature completion, or they force feature compliance for it. So that just feels like they're spying on me. I don't know what they're spying on me for. It just feels like it. Right? I just feel like I'm getting, are we using Vim in 2024? Yes, I Vim. I Vim hard. Anyways, okay. Let's see the Go command. Setting the Go root final environment. the Go root final. I'm glad that this no longer has an effect. Good. And distributions that install the Go command to a location other than Go root bin Go should install a symlink instead of relocating or copying the Go binary. The new Go env changed a flag causes the command to print only those settings whose effective values differ from the default value that would be obtained in an empty environment with no prior W flag. All right. The new Go mod tidy diff flag causes the command not to modify the files, but instead print the necessary changes as an unified diff. It exists with the non-zero execute code or non-zero code if updates are needed. Okay, that's cool. That's cool to see what you're doing. By the way, go mod tidy is a very strange command for get the packages that I need that I have referenced. Go mod tidy is one of those things that I just feel so weird about, in the sense that for me to find the package, I have to go to GitHub to figure out where it is, or GitLab, or wherever it's being stored. I get the reference, then I put it in my package, and then once I put it in there, then I have to execute go mod tidy to bring it into the mod. It just feels funny. Well, some people are saying I think tidy is the wrong word. Well, the reason why it's interesting, I believe if you don't use the package, it will remove it from your package. Yeah, you can go mod download. It feels funny, right? That whole experience feels funny, though I do like it. It's better. Go mod tidy is great, but I also find that I will get things break, and then I'm like, go mod tidy, and then things don't break anymore, and you're just like, okay, I don't know what went wrong, but all right, hell yeah. The go list m JSON command now includes a new sum and go mod sum fields. Okay, I don't think we care about that. What is vet? Go vet subcommand now includes standard version analyzer, which flag references to symbols that are too new for the version of Go in effect in the referring file. I think I'm too stupid to understand that. For example, it will report a diagnostic for a reference to the reflect.type4 function introduced in Go 122 from a file in whose module specifies Go 1. Oh, interesting. Okay. Cool. Cgo now supports. I've never used Cgo. What the heck is Cgo? I've never tried linking C. I wonder if you can link Zig. Could Go become the new? Oh, that'd be cool. Because the one reason why I wanted to start getting better at Python is A, simple problem solving, but B, I wanted to be able to solve all my problems in Zig that are slow and then use Python as like my loosey-goosey side of things. And so it'd be kind of cool to see what this does. I've never played with this. The trace tool is now better. Tolerates partially broken traces by attempting to recover with. Okay, cool. I love any tool that acts like HTML. HTML is the most resilient tool in the universe. No matter how shitty it is, it just works. It just runs. I love that. I love when you pass and break and stuff, and broken stuff works. Traceback printed by the runtime after an unhandled. Oh, let's see. A traceback printed by the runtime after an unhandled panic or other fatal error now indents the second and subsequent lines. Cool. Compiler build time overhead with building a profile-guided optimization has been reduced significantly. Previous large builds could see 100% plus build time increase from enabling PGO. In a 1, 2, 3, overhead should be a single digit percentages. Classic Go W. That's one reason why I love Go right here. It's so good that if you're using something like AIR, AIR, you're able to update your website, restart your server, and by the time you go to your browser, it's already in. It's really, really nice. It's really, really, really nice. I do like that rebuilding. Anything? Linker? Meh. Nothing for me here. Timer changes. Makes 2 significant changes to timer. Okay, what happened here? First, timers and tickers are no longer referred to by the program becoming eligible for garbage collection immediately, even if their stop methods have not been called. Earlier versions of Go did not collect unstopped timers until they had fired and never collected unstopped tickers. Okay, second, timer channel associated with timer and ticker is now unbuffered with capacity 0. The main effect, of this change is that Go now guarantees that for any call to reset or stop method, no stale values prepared before that call will be sent or received. Oh, nice. Okay. I use timer, but I've never ran into any of these. Timers go boom, boom. Yeah. Okay, that's cool. I've never used any of this. New unique packages provide or facilitates for canonical values like interning and hash concise consign. What is this? I don't know. I don't know. I don't know what that is. I'm not a hash guy. I don't know. I have no idea. Any value? Let's see. Any value of comparable type may be canonicalized with the new make t function, which produces a reference to the canonicalized copy of the value to form a handle t. 2 handle t's are equal if and only if the values used to produce the handles are equal, allowing programs to deduplicate values and reduce their memory footprint. Comparing handle t values efficient. Reducing down to a simple pointer comparison. Oh, I'm not sure if I really get this. Are they just saying with a bunch of words that it just compares the pointer handle? I don't know. Anyways, iterators. The iterator package, I'd have to think about this more. I don't really quite. Java equals handle D. Yeah, handle Ds. Yeah, absolutely. The slices package now, adds several functions that work with iterators. All values backwards, collect, append, sort, sorted func, sorted stable func, chunk. Oh, chunks over an iterator? That's pretty cool. Map package adds several functions. All keys, values, insert, collect. This is actually pretty cool, by the way. This is pretty cool that we're starting to get these type of functions. Like collect is if it's what I'm thinking it is, which is take a map and turn it into a single value. Collect, collects key value pairs from a sequence. Nice. Okay, so it collects from a sequence into a map. That's cool. That's cool. Okay, that's awesome. That means you can have a sequence and actually create a map from it. So map from sequence just got real easy. The structs package provides types for struct fields that modify properties of the containing struct types such as memory layout. All right, so how does this work? In this release, the only such type is host layout, which indicates that a structure with a field of that type has a layout that conforms to the host platform expectations. Is this H to N? N to H? Is that what we're hearing here? I don't think I quite understand this. This is probably too low level in Go for me to understand because I don't have that deep knowledge of Go. Contains filtered or unexported fields. Host layout marks a struct as using host memory layout. A struct with the field of type host layout will be laid out in memory according to the host expectations, generally following the host C ABI. Oh, is this for better communication between C and Go? Okay, I don't quite understand that one. And then there's a bunch of other stuff that I don't think I'm gonna look over. I saw something about the word Windows in there, but there's a lot of changes. It looks like a lot of little changes in here. A lot of new build stuff going on here. Cool, awesome. Go 1.3. Go 1.23 looks really good. I'm actually very excited. I really love the idea that they're leaning into ranges, which I think they should have done literally a decade ago. I'm happy that we're here, and I'm happy that generics are actually. There's a lot of cool stuff. I think Go is much more powerful than people realize. And I really wish I could find this one. I can't remember what I was using it for, but it had a really cool generic operations. And so I think there's a lot. I think there is actually a lot with Go that I just need to practice with, especially this whole returning anonymous structs based on generics and creating a generic struct interface. What I'm curious about is if you create hold on, I know somewhere in here I had this. Ow. I'm curious about this. When you have this, can you also do this, or can you not do this? Is this just not allowed? Can you not define functions on this? Whoopsies, wrong language. Format. Why aren't you working? Print F, hello. Let's see. Man, I keep mixing up Zig. There we go. So I can print that and return 1. Can I do that? Or is that not allowed? It doesn't look like this is allowed. Let's find out. Okay. So it looks like you can't attach functions. I bet you there's a way to attach functions to this that I don't know. You can do funcs inside of funcs? Yeah. I bet you there's a way to do this that I just don't understand. Typo and func? Where? What did I do? Function, receiver, name, no arguments, return type? I don't know what's wrong with that. Interfaces. Yeah, see, I don't think I quite understand. Func is not fun. Oh, you could use interfaces. Oh, interesting. So I could use an interface? I don't think I get it. I don't think I understand how to use an interface there. Anyways, I'll have to look at this later. Either way, I think that there's a lot of fun with Go coming up that I need to play more with. And I think I just need to understand that part because I feel like I get Zig much better. Zig is more simple and therefore easier in my head to use. It just is. But it doesn't have this ranging thing that Go has. So, anyways. Zig vtables. Yeah, that's the thing is you just create what you need to create, right? If you need to have an interface, you have to create a vtable. Maybe there's something that could be easier about Zig there. The thing is that the problem is with Go, I love structural typing. And I want structural typing in every other language I ever use. And that's my big problem, is I love Zig, and Zig might be one of my favorite languages of all time. Yes, I think Zig is simpler than Go now, in some sense, because Zig is exactly what you think it is. Right? It literally is exactly what you think it is. It's just, you want memory, it's right here. Oh, you need to create memory, you create memory. It's when I say simple, I mean it that way, right? Zig is for dummies. Zig is Go for dummies. No, I'm not sure how to even say it that way. Go's type system feels good. Yeah, it's because of structural typing, right? Anyways, all right. Hey, I'm not sure which way it is, but hey, the name is not Caboose, a gen.